Hi, everyone. Welcome to Distant Learning. Let me give you a general outline of what our time together online is going to look like, and then later on we'll talk a little bit about work. So usually on our class days, which are Tuesdays and Thursdays, you're going to watch a short video just to introduce the material for that day, and it'll most likely be followed by some sort of short activity that will allow you to practice with the new material. Um, and of course, more specific instructions will be given on Classroom each day. Um, so for today, so that we can kind of ease into this whole distant learning thing, I want us to review this idea of work. And it turns out that later on, when we move into our study of simple machines, this idea of work is going to be super important in understanding how simple machines work. So um, let's look at work. So remember, work in physics is how we give things energy. That's how we give things energy. So we can give something kinetic energy. If we want to move something, give it kinetic energy, we have to do work on it first. Okay. We could also lift something up and give it potential energy. I happen to have your Fusion book right here. If I lift the Fusion book up a certain distance, I just gave it a little bit of potential energy. And I gave it potential energy by doing work on it, okay? We could also do work on something to give it both potential and kinetic energy. For example, when you punt a ball, like this guy's doing right here, he's doing work on the ball, and because he did work on the ball, he gave it kinetic energy, and then eventually some potential energy as well. The amount of work you do depends on two things. If you remember, the amount of work depends on the force that you apply and the distance that you apply it for. Let's look at a rocket launching into space, for example. Uh, we obviously need to give this rocket a lot of potential and kinetic energy. And in order to do that, the rockets are going to do work on the rocket itself to lift it up, give it potential energy, and make it move, which is giving it kinetic energy. But the rocket engines, they can't just apply a force. They have to apply a force over a certain distance to lift it all the way into space. Okay? So remember, the equation for work is force times distance. You have to apply a force over a certain distance. Let's run through a quick example here. So my apartment is on the second floor of this building. That means every day I have to lift my body weight up to a second story. So let's calculate how much work I have to do every day to get myself up to my apartment. So remember that the equation for work is force times distance. So let's start there. Work is force times distance. So we need a couple bits of information here. Okay, so, well, what is the force? Well, the force that I need to apply in order to lift myself up is the force of me or my own weight. So the force is actually going to be the weight, which if you remember is equal to my mass times gravity. And now we need distance. Well, distance is just going to be how high up I need to go. So let's just say that um, for simplicity, let's just say that I need to go up 5 meters. Okay. I guess we should also get a number for the force or my weight. Let's just say I'm 70 kilograms. And we know that G is 9.8 meters per second squared. Okay. Um, get my calculator here. 70 times 9.8 is 686 kilograms in a meter per second squared. That's a newtons. Okay, 686 newtons. So if I want to figure out how much work it took to lift my body weight up 5 meters, we're going to do the force, which is 686 newtons multiplied by 5 meters. When we do that on the calculator, oh, that might be backwards. 3,430. Now, what are the units of work? Well, remember, when we do work on something, we give it energy. When I walk up those stairs, I have to give myself potential energy. Or if you remember, the units of energy are joules. We'll write that with a big J. So it takes 3,430 joules of work to lift my body up to my apartment. Keep in mind, though, that this would be the same case if, let's say, I took the stairs, or let's say I climbed up through one of my windows. Okay, it doesn't matter the path that I took to get up to this 5 meters. All that matters is that I applied that force over that certain distance. Okay, and again, when we study simple machines, this idea of work will become increasingly more important. So if you have any questions about that, feel free to stop in during my office hours. Our classes meet on Tuesdays and Thursdays, and my office hours for physical science start at 1 p.m. on Tuesdays, Thursdays, and Fridays. Okay. So for your activity for today, what I want you to do, I want you to read pages 80 to 83, 80 to 83. You can just read them. I want you to do the work problem though as well. So read the pages 80 to 83 and do the work problem. And then I want you to be mindful throughout your day of all of the times that you are giving something work. When you're doing work on something or giving it energy. And I want you to record those. There'll be more instructions about that on Classroom that you can follow. So if you, like I said, if you have any questions, feel free to stop into my office hours. If it's a quick question, you can email me as well. Other than that, have a good day.